Okay, so once again, good afternoon to one and all present here. So the today topic actually is applying object-oriented design in game development. So this semester, all belong to third year student. Third year, all belong to third year. Can you respond? Okay. So the actually, if you are in third year, you are having that subject object-oriented analysis and design. So as a part of that subject, you know about what's the purpose of that object-oriented analysis and design. So based on that, here all the way. So nowadays, actually, it's a need of hour. It's like a lot of game-oriented applications is coming up. So in that cases, next to one to 1.5 hours, I'm going to discuss about how actually we are developing the game based on that object-oriented design concept. So we know that object-oriented design, it has become a cornerstone in the modern game development, that enabling the developers to create the complex, flexible, as well as the scalable game architectures. So with the increasing demand for the intricate the gameplay mechanics and some kind of interactive environment and even the dynamic user experiences, so that's a need for the structured and maintainable code. That's a very essential for such kind of development, game development. So that's why the object-oriented design that provide a framework where the game elements. So whenever we talk about the games, we know a very important thing. The character is very important. Environment is very important. So what kind of system we are making it, that's very important. So that's why whenever we go for developing any game, these three things is very, very important: character, environment, and the system. So that are organized into classes and object. So as a part of that object oriented, we know whenever we talk about the object oriented programming or OOPS concept, this a class object is very, very important. So everything is make it in the class. So C with the classes is object oriented concept. That's a thing like inheritance, polymorphism, what are the abstraction and encapsulation and so on. So whenever we talk about such kind of what a thing here, we are making all the character, environment, and the system that are organized into the classes and object. So through that object and classes, we are making it somewhat easier to manage, reuse. That is a reusability with the help of the inheritance, and even extend these components as a game evolves. So that's a very, very important thing. So that's why by leveraging these object-oriented design principles, such as we may already I told that encapsulation is very, very important, inheritance is very important, polymorphism is very important. So these principles, object-oriented design principle like encapsulation, polymorphism, and inheritance, here the game developers can encapsulate the behavior and attribute within the modular and the self-contained object. So that's why this approach is not only enhances the code readability, but also it enables the efficient collaboration among the team members by actually through the users, end users, or even the developers. So by promoting the reusable and the modular code components and so on. So that's why, furthermore, the use of common object-oriented design patterns like we may say the factories and singletons. Actually, that concept is available in the object-oriented analysis and design. So that we'll elaborately discuss in the upcoming slide. So that helped the streamline the resource management, object creations, and complex gameplay mechanisms. So with this short introduction, just I am starting my session. So the topic is mainly for developing the games based on the object-oriented, applying the concept of object-oriented design. So next to 1.5 hours, we are going to discuss about the introduction to the object-oriented design in the game development and the core object-oriented concept in game design. And apart from that, there are key design patterns in the game development. What are the key design patterns to be followed while designing the games? And the next thing is the modeling game objects using classes and the level design and scene management with object-oriented design. artificial intelligence in games using OOAD. A lot of games nowadays, a lot of games are available based on the AI using the OOAD concept, and some case studies, some 5 to 6 what are the games, popular games, based on that object-oriented design, how that stuffs are created. So that we are going to discuss as a part of case studies, and the future trends in the object-oriented game development, and finally conclude the session with the conclusion. So this is the overview of today's sessions. So next 1.5 hours, we are going to discuss about these 9 points. So the first we'll go with the introduction to the object-oriented design in game development. So whenever the overview of the object-oriented design principles. So here the object-oriented design principles that provide a structured framework for the organizing the code in a way that's a modular, reusable, and scalable. So these three features, the modular, and modular is what is based on the class and method concept. Reusable is inheritance, and scalable is based on the polymorphism and other concept. So these principles, this the modular, reusable, scalable principles are the foundations. It's a foundational one to creating the software system where the component can be easily understood, extended, and even maintained. So that's why this OOD principles revolve around the core concept that support the modeling of the real world entities and behavior within the software. So that's a very important entity, and that's a real world object, and methods or behavior of the particular object. So that's everything can be make it within a software. So that's why here actually we are in that overview of the main principles in the object-oriented design. Is the first one is the encapsulations. So we know encapsulation is nothing but wrapping up both the data and behavior in the within the system itself. So the encapsulation is a practice of bundling an object data, that's an attribute, and a method, that's a behavior or functions, that manipulate the data within a single unit or class while restricting access to certain details like that. So that's about the encapsulation. So this principle hide the internal implementation detail of the class from the outside world. That's a thing. That's why whenever we talk about the encapsulation, here the data abstraction will be applicable. So something will be hidden outside the world. So based on the access specifiers and other things, that's already studied in the object-oriented programming concept. So that's why something is restricting access to a certain detail and so on. So that's why this principle, this encapsulation, hide the internal implementation detail of a class from the outside world, that exposing only what is necessary through the public methods. So whenever it declared as whenever it's specified as a private, it won't be accessible. Whenever it's specified as a public, it will be accessible in the outside. So that's why that kind of restriction, that kind of restriction will be given for accessing the data. That's a very important thing in the encapsulation. So through that restriction only, we are making it in the abstraction or something. So the abstraction is nothing but that's the next we'll see the thing. So as per that abstraction is mainly focuses on the representing the essential features of any object without deriving into the unnecessary complexity and other thing. So abstraction is nothing but sometimes we may say it's a hiding, but not exactly hiding. See the abstraction in the sense everything is available, but based on the perception, based on the user perception, something is hiding, something is visible like that. So that's the thing. That's the idea behind the abstraction. But normally, whenever we talk about the abstraction, we may say the data hiding concept, but not exactly the hiding, but the perception. Based on the perception, it can be varied. That's the second principle design. The third one is the inheritance. So we know that inheritance mainly to allow the users or allow a class to inherit the properties and behavior from the another class. That's a superclass and subclass like that, parent class and child class like that. So this principle support the reuse of the existing code and even enable the hierarchical structure or hierarchical relationship among the classes. So that's why in that inheritance, mainly we are having the is-a relationship, whole part like that. So is-a relationship in the sense the particular class is a child of the particular class is a child of that. It's a parent of this like that. Okay, it's a relationship, a whole part and like that. That's about the inheritance. And fourth important thing is the polymorphism. So the polymorphism, it allows the objects of the different classes to be treated as the instances of a common superclass and it enabling one interface to support the multiple underlying forms or the implementations like that. So through the polymorphism, the same method can before differently depending on the object and it's being acting upon like that. So that's the thing. So that's why it's a polymorphism. Actually, it's a same name, different form like that. Given the operator, a lot of types, operator overloading and function overloadings are there like that. The next design, object-oriented design principle is the composition. So the composition is an alternative to the inheritance. Already I told the inheritance is a relationship, but whenever we talk about the composition, it may be called as a whole part, has a relationship or like that. So that's why the composition is a kind of alternative of the inheritance that involve the creating the complex types of combining the objects and other types rather than the inheriting from the superclass or some other thing. So that's the thing. So whenever we talk about the composition, that every composition promote has a relationship. So the car has an engine like that. So the superclass and subclass. So here we are using the relationship as a has. Yeah. So the car, whenever we talk about the car as an object, so the car has a engine. Have an car has an engine like that. So that kind of things. That's the thing. And next thing, actually, another thing. When, am I audible? Are you able to see the fifth slide? Slide is moving. Anyone, can you respond? Are you able to see this fifth slide? Anyone? Anyone? Can you respond?
Yes, sir.
Yeah. Okay. Thank you. Okay. So next, whenever we talk about the overview of OOAD principles, very important thing, key design patterns. That's for that mainly for supporting the OOAD principles. So here the OOAD principles are often implemented through some common design patterns, which provide the proven solutions to the frequent design challenge like that. So in that case, the first one is a factory pattern. So already you studied about the different design pattern in that OOAD subjects. The first one is a factory pattern. So the factory pattern is used to create instances of any classes in a flexible and centralized way. That's about the factory pattern. The factory pattern is nothing but it's useful for creating the instances of any classes in a flexible and what is the centralized manner. And second thing is a singleton pattern. Singleton pattern is nothing but it ensures that only one instance of a particular class that exists within a system that are often used for what is driven the systems. That's mainly for managing all the global resources and something. And the next observer pattern is nothing but it supports the loose coupling by allowing the objects to notify the other object of the changes that are often used in the event-driven systems like that. And fourth pattern, design pattern, is a decorator pattern. Decorator pattern is nothing but it mainly adds the functionality to objects at the runtime, supporting the flexible feature expansion like that. So that's the thing. And next thing is a modularity is another kind of design pattern. So the design pattern, that modularity is nothing but here the code is organized into independent units, which makes the easier to understand and maintain like that. And next thing is the reusability. So reusability is nothing but the code is actually code and classes and objects. It can be reused across the different part of the system or even in the other projects like that. And next thing is the extensibility. So the extensibility is nothing but here the system design with the OOAD principle or the somewhat easier to extend with the new features or any kind of modifications and so on. And finally, the maintainability. So the maintainability is nothing but here the object-oriented principle that support the code that's easier to debug, test, and refactor, ultimately leading to more what is the stable and adaptable software. So that's why here object-oriented OOD principle that provide a powerful framework for designing the software that's a modular, flexible, and easy to manage, and so on. So that's about the overview of the object-oriented design principles. So here we are using the different key design pattern from the factory pattern to the maintainability. That's a very, very important. And next thing is the importance of OAD in the game development. So why we go for that such kind of game development? So here the object-oriented design is it's an essential in game development, and also it provides a structured approach for building the complex, dynamic, and scalable game system. That's a very, very important. So whenever we talk about the advanced level of games, the game should be a dynamic manner, and it should be in complex manner, and also it will be adaptable in the scalable. These three parameters is very important. Three features is very, very important. So that's why with the games becoming the increasingly sophisticated, here the developers need to manage the diverse elements such as characters, develop environment, some kind of physics, some AI, artificial intelligence, and even in the user interactions and so on. So that's why here object-oriented design (OOAD) help they organize this element like character, environment, AI, physics, and user interactions in a modular, reusable, and maintainable way for allowing the developers to create engaging and flexible game experiences and so on. So that's about the importance. So that's why that what object-oriented design is so important in game development. In the sense, the first one is the modularity and code organizations. So here, the second thing is the reusability and efficiency, and third one is the scalability and flexibility. Fourth is the collaboration, improved collaboration, and fifth one is the enhanced maintainability and debugging. And sixth one is a support. It supports all the way. It supports the complex game mechanics and AI. And seventh one is the reuse management, resource management, and the performance optimization, like that. So the first we'll see about the modularity and code organizations. See, in that cases, the OAD enable the developers to break down the game into a discrete, manageable, and different classes. Each are representing a specific aspect of a game. So that's the thing. So based on the modularity, by encapsulating the behavior and attribute in the classes, like whenever we talk about the game, the player is very important, enemy is very important, weapon is important, and what kind of environment we are using it, that is very important. For developers can organize the code in the logical structure like that. So that's why this modularity that makes it easier to locate, update, and debug the specific part of the game without affecting others. So that's a very important about that modularity and code organization. And second important is the reusability and efficiency. So with OAD developers, that they can create the reusable component that can be shared across the multiple parts of the game, or even across the different projects and so on. So for example, a character class. So it's here example is the character class with the shared property like health, position, and movement, speed, that can be used as a base for the different game character, that reducing the redundancy and also saving the development time and so on. So that's why the reusable classes and component also make it somewhat easier to develop the sequels or expand the games by reusing the existing code and so on. And third one is the scalability and flexibility. So here the games are often updated with the new level characters and features. So the OAD principles like the inheritance and composition that allow the developers to add the new element without rewriting the existing code and so on. So for example, whenever we talk about the scalability and flexibility of what is the game OAD in game development, they are adding a new character type may simply involve the creating the subclass that inherit from the existing character class, or even overriding the specific method and so on. So that's why the scalability makes it somewhat possible to grow the game over the time while maintaining it stable over the code base or something. And next thing is a collaboration, improved collaboration. So here the game development often involves the large teams of designers, programmers, and artists. So that's why here the OAD will facilitate the collaboration by providing a clear structure that team members can follow and build upon. In that cases, with each element, whenever we talk about the improved collaboration, with each element of the game represented as an independent class, the team members can work on the different part of the game simultaneously without stepping on each other's toes and other thing. That's a very important thing. And another importance is the enhanced maintainability and debugging. So whenever you talk about the enhanced maintainability and debugging here, the games are constantly tested and tried to improve the player experience, the balanced gameplay, and even fixing some kind of bugs. So here, OAD mainly they promote the encapsulation for the maintainability of the code, and which isolate the different parts of the game and make it somewhat easier to identify and resolve the issues and so on. So because of these, each object has its own state and behavior. The developer can pinpoint the bugs within a specific class rather than sifting through the tangential code base and some other thing. And next, it support the complex game mechanics and artificial intelligence AI. So here the OAD is specifically valuable for implementing the complex game mechanics and artificial intelligence behavior. So in that cases, with the inheritance and polymorphism, the developer can create a flexible hierarchies where that different game entities say share the common set of behavior while having the unique features and so on. So that's why in that cases the inheritance and polymorphism concept is very useful for such kind of complex game mechanics as well as the artificial intelligence. So for example, a base enemy class can define the general behavior, while the specific enemy type like zombie and alien inherit this behavior and introduce their own characters like that. So some of the use cases we'll discuss in the end of the session. So in that cases, different types. So the enemy type may be a zombie and alien. So that's the thing. And this approach allow for the rich and varied gameplay and more sophisticated AI behavior like that. And next, the resource management and performance optimization. So in that case, here OAD makes it somewhat easier to manage the resources some efficiently, and also important factor in the game performance. So that's a very, very important thing. In that cases, the singleton pattern, for the example, it can be used to ensure that only one instance of global resources like audio or physics engines or anything is created. So that will be there. So this avoid the unnecessary memory usage and keep the resource management in the streamlined manner and so on. So in overall, whenever we talk about the importance of OAD, here is the fundamental approach in game development that allow for the structured, modular, and efficient design and so on. So this is about the importance of OAD in the game development. And next, what are the core object-oriented concept in the game design? So whenever we talk about the how these core concepts are applied in the game design, that's in that cases here actually whenever we talk about the core object-oriented concept, encapsulations, inheritance, and polymorphism and abstraction are the fundamental for the structuring and implementation of the game design. So these concepts enable the developer to create the modular, reusable, and scalable code, helping manage the complexity of the modern games and so on. So here, how this actually whenever we talk about the things, the first encapsulation is the first concept. So actually, this slide will be very useful for you. How whenever we suppose if you are familiar, if you are actually somewhat expert for developing a game in the sense how that OOD concept are applied in the game design. So here the encapsulation is a concept we know is a bundling of the objects and that objects data and behavior within a class and restricting access to a certain detail and so on. So that's why this keep its internal state of the object hidden from the outside world or other part of the game and so on. So whenever you talk about the encapsulation, in very particularly in the game design, it's used for creating the self-contained game object like the player, enemy, or any item. So each with their own data as well as the behavior. So for example, a player class, the player is a one class. It might have the private variable for the health, position, and inventory. So that's applicable to only the player class. So it can only be accessed or modified through that specific method alone. So that's a kind of hiding the concept. So that's why this ensure the player state is protected from the unintended changes or making it somewhat easier to debug and even some kind of controlling the interactions and so on. And what are the benefits for the using the encapsulation concept in the game design in the sense it all the way this encapsulation it promotes the data security and also it reduces the interdependence between the component and it allows the developers to make the changes from one part to the another part without breaking other parts and so on. So that's a very important thing. So that's why we are using encapsulation concept in the game design. And second concept is the inheritance. So we know the inheritance mainly to allow the classes. It may be a child or subclass, super class, or that's a parent, a base class or the child class, to inherit this attribute and method from the another class. That's a parent or super class like that. So in that cases, the game design here is commonly used to establish the relationship among the game object. For example, a base class character might define the common property like a health, movement, and attack. So here the subclasses such as a player character and enemy character can inherit from the character sharing because it's a common character, common property. So that property is available in the base class itself. Even we can call it in the subclass itself. That adding the unique behavior or attribute like that. So that's a very important purpose. That's it's happening. And in a game with various enemy type, each enemy can inherit from the enemy base class, making it easier to manage and extend the behavior of that enemy like that. That's another kind of concept, object-oriented concept in the game design. And the benefits, mainly the benefits, it's reusable code duplication. That's a reusability that provide a clear class hierarchy that simplify the adding the new characters or what entities with the shared characteristics, making the game somewhat more and scalable manner. So that's about the thing. And third, what the concept is polymorphism. So that we know the polymorphism, it allows the object to be treated as the instances of their parent class, even when they belong to the different subclasses, that enabling the user of one interfaces to support the multiple implementation and so on. But very particularly in the game design, polymorphism is useful for managing the collections of diverse game objects. So that's a very important thing in that case. For example, whenever we are designing any games, that's a NPC, that's a non-player character game. In that game, we have the multiple characters, the example player, enemy, NPC. So each with its own specification, specific implementation of a method, any like update or some other method. So in that cases, with that polymorphism concept, a single loop can update all the characters by calling the update method on each one, regardless of its specific type and so on. So that's why this makes the somewhat easier to handle the variety of objects with the shared behavior like drawing, updating, interacting, and so on. So that's about the game design. And the benefits of polymorphism in that game design is it enhances the flexibility and also allowing the users or developer to interact with the variety of object in some uniform manner. So that's the thing. That's why it also, the polymorphism also simplify the code as the developers can use the common method across the different objects and enhancing the extensibility and the adaptability concept like that. So that's the thing. And next concept is the concept is the abstraction. So we know the abstraction mainly focuses on simplifying the complex system by representing the essential features without delving into the unnecessary detail like that. So that's why this abstraction concept allows the developer to create the high-level interfaces or the abstract classes that define the what of an object, leaving the how to subclasses like that. So what and how keyword will be used in that abstraction concept. So in the game design, mainly whenever based on that game, the abstraction concept will be very useful for managing the complex system by defining the clear interfaces for game component like that. For example, the abstract, the weapon class may define the general method like attack and reload, while the specific weapon types, sword or gun, implement these methods differently based on their unique behavior and so on. So in that cases, the method is common, but based on the types, it will be the what the behavior will be changed. So that's why here it's called as a hiding the thing, but not exactly hiding. Actually, here the perception. That's why it's called as abstractions. So that's a happening all the way happening. This allows the developer to design the game systems with a broad functionality, making it somewhat easy to swap or extend the behavior without changing the overall game architecture and so on. So the benefits of abstraction concept in that game design is mainly to improve the code clarity and also reduces the complexity of all the system and enable the developers to design the flexible system where the different component can easily fit into the predefined interfaces, and so on. So that's about the how the core concept, like a Wood's concept, are applied in the game design. So very particularly, these four concepts will be a very important for while developing such kind of game based on the object-oriented design concept like that. So next is the practical applications of the Wood's concept in the game development. In that cases, in game development, this Wood's concept that come together to create a flexible architecture of for building the different gameplay system. So here are some of the example of how the Wood's concept combine in the practical game design. In the sense, the first game is a game characters and NPC. So non-playing character, the game character and NPC. Here, actually, it's by using the inheritance concept, a base character class can define all the core properties and method, while specific characters like the player, enemy, and allies that extend the base class with the unique behavior and so on. So that's why here, whenever we talk about the game character and NPC, here the polymorphism concept that allow the developer to iterate over the all character and update them through the shared update concept and method or some specific character type and so on. And second practical application is item and inventory systems. So this is a kind of another kind of game here with here actually mainly they are using the encapsulation concept. Why? Because everything will be wrapping. The both all are wrapping up into the single unit. That's the encapsulation. So here the inventory system can manage the item within the player's inventory privately using the public method to add, remove, and use the item. So that's why whenever we talk about the this item and inventory system, whenever here the encapsulation is very important. Already I told you, whenever we talk about the encapsulation, the abstraction is very important. So here, abstract classes or interfaces like item can define the method like use or some specific item and so on. And next thing is the event and UI systems. So event-driven systems can often utilize the encapsulation and the abstraction concept. So that's actually event and UI system mainly uses the encapsulation and abstraction, where each event listener or handler is encapsulated within its classes like that. And even the polymorphism also allowing the different events. It can be processed uniformly, while inheritance provide a way to create a specific event types like that. So that's the thing. So that's the practical application. These three applications. I will repeat once again, the game character and NPC. Here mainly they are using the inheritance and polymorphism. And second application is the item and inventory system. Here the item and inventory system mainly uses the encapsulation. In that, whenever you talk about the encapsulation, the abstraction is also there. And third, event and UI system. In that case, mainly it follows the polymorphism and abstraction concept. That's the thing. That's a practical application of Wood's concept in the different game development like that. And next, the benefits of applying the Woods in the game design. A lot of benefits are there. So first, enhance the maintainability. And here, whenever we talk about the maintainability, here all the way the enhancing the maintainability. Here the encapsulation and model code organization make it somewhat easier to debug, test, and update the specific game element and so on. And second thing is a code reusability. So code reusability, we know it uses the inheritance and polymorphism concept. It reduces the redundancy, allowing for the shared behavior across the different game objects and reusable components. And third one is the greater flexibility. So whenever we talk about the flexibility, the benefits of oops in that game design is a flexibility. Here the abstraction and the polymorphism, it's make it somewhat easier to extend or modify the system, supporting the scalable and game development. And finally, it's a collaboration. It's a kind of improved collaboration. Actually, in that improved collaboration, it's a clear and a structured code that enable the team members to work on the separate component, like it may be simultaneously or speeding up the process like that. So that's about the benefits of applying the Woods concept in game design. And another thing is a key design patterns in the game development. So what kind of design patterns we are using it while designing such kind of games. So in that cases, it's a lot of things to be needed. So in that game development, the design patterns are essential tool that help the developer to solve the uh, some kind of recurring problem, and even some organized code in a structured as well as the efficient manner. So that's why here the whenever we talk about the key design patterns, here the games often involve the complex interactions, state management, and even a resource intensive operations. So which can make the development challenging without a solid architectural foundation. So that's why here the design patterns provide the standardized solution to these problem or these challenges, that making the code somewhat easier to understand, maintain, and even scale like that. So for example, whenever we talk about the pattern like singleton, it is very useful for creating the centralized manager, while the component patterns are allow the game object for the building these flexible and modular what are the parts and so on. So that's about that. So here the first thing is the entity component system pattern, ECS. So as per that ECS pattern, it's a kind of popular design pattern in a game development that provide a flexible and scalable way to manage the complex game object and their behavior. So that's why the ECS is commonly used in the pattern, the modern game design engines, and it's well suited for the game that involve the many entity, such as it may be the entity may be a character, or it may be items, or it may be any environmental objects and so on, with various attribute and behavior. So that's why here, as per that, actually here the diagram, we are having the ECS entity component system pattern. So what are the key concept of ECS is nothing but whenever we talk about the key concept of ECS, entity component system, the three important thing: entity is very important, component is very important, system is very important. So name itself. So the key concept of ECS is entity, component, and system. So the entity, we know it's a real world, or it's a general purpose object, and that act as a container or an ID for the component like that. So it represents the distinct game object and also hold the node data and behavior on its own like that. And second uh, key concept of the ECS is the component. The component, actually here, see the thing here, entity is there, component, this is the entity. So this entity is a general purpose object that act as a container for the ID for the different component. But next thing is a component. So here the every entity having the some kind of component. So in that component is hold the data or the property that define the characteristics of an entity. So that's for example, the character in any game, component like position, health, velocity, and even sprite and so on. And third thing is a system. So here this is a system. In that system, it contains the logic and behavior of that behavior that operate on the different components like that. So that's why each system run on the based on that only. And how the ECS is work. So how it works, how that ECS entity component system is working in the sense here in an just see this diagram. So as per this image diagram here in an ECS architecture, here the entities are created and populated with the component that represent their property. Next here the systems can query, then actually query the entities for the entities with the required component and perform the operations on them. So for example, we may say the movement system, whenever the movement, any kind of movement system that will look for the entity with the position and velocity component that updating their position accordingly like that. So that's about the working principle. And the advantages of entity component system is it's in terms of performance, in terms of flexibility, in terms of reusability, and some kind of decoupling and other things. And some example use cases. See, if, whenever you go for using any game, very particularly in the shooter game, the different types of enemies may have the health and position component. So while that the projects may have the velocity and the damage component and so on like that. So this is about the ECS, entity component system. It's a very important key component of object-oriented system, object-oriented design in the game development like that. And second, next thing is a singleton pattern for the game manager. So we know the singleton pattern is a design pattern. It's used to ensure that a class has only one instance, and it also provides a global point of the accesses to that instance like that. That's why this is particularly useful in game development for managing the resources or the any data that need to be consistent and accessible through the entire what is the game and so on. So that's why very particularly in game, the singleton pattern is commonly used for the game managers. Like the game manager is called as a centralized controllers that manages a specific aspect of what the gameplay of the different resources and so on. So the why singleton for the game manager in the sense here the game managers are often need to be globally accessible and consistent across the different game objects and the scenes. So for example, actually all the way what whenever we talk about the what game manager in the singleton pattern, here the need to be globally that accessible and consistent across the different game object and scenes. But example, suppose consider system like we may say audio manager. In that cases, the audio manager, the game state manager, the input manager, or some kind of user interface manager, and so on. So that maintain the single what is the cohesion what are the across the throughout the entire session, game session like that. So based on that, by implementing these behavior or these managers as a singleton, the developer can ensure the unique access and simplify the access and also optimize the resource management and so on. So this is about the singleton pattern for the game manager. And in that cases, the different use cases are the common use cases for the singleton game manager. So in that case, different. One is an audio manager. It all the way it manages all the background music, sound effect, and volume control. Second is a game state manager. It tracks the game progress, player state, level data, and scores like that. And the input manager is mainly process the player's input and interpret it across the different game object and like that. So using a singleton for the different input management that ensure that only one set of control is replayed across all the scenes like that. And finally, it's a UA manager. All the way the UA manager is handled in-game interfaces like score display, health bar, and notification, and so on like that. So that's about the thing and how we are implementing the singleton game development in the sense. Here is a typical example of the implementing a singleton pattern in the game development using the C#. That example. This is a one code. Is a game manager is that. The game manager having the mono behavior is a behavior, it's a method. So under that method, a lot of even what are the attributes and activities are there. And next thing is a awake. So in that cases, normally in this the instance provide the global access. Here actually here is the instance. It's a one object or one what is the variable. Here the instance is mainly provide the global access point for the game manager. And awake is a method. Previously, in the previous thing, here we are using the what is the method? One is the awake method. So the awake this method mainly is useful for only one. It's only one instance, and it will destroy any duplicates. And next is the don't destroy on loads. So this it's actually it's persist across the different scenes. So this keeps the instance alive across the scene transition and so on like that. So that's about the singleton pattern. And next thing is the observer pattern for event handling. So whenever we talk about the observer pattern is a key design pattern. Observer is a key design pattern for even any kind of event handling. It commonly used in the software system to enable the one-to-many relationship between the objects. So it allowing for them for more efficient and decoupled event management like that. That's why in this observer pattern, when the object changes its state, all the dependent objects that observer are automatically notified and updated. That's a very, very important that observer pattern. And the key concept of the observer pattern is nothing but here the subjects and observer. So subject is an object whose state changes triggered based on the trigger notification, and observer is a it may be called as call it as a subscriber, and mainly for the object that we wish to notify of the changes in this subject like that. Second thing is a loose coupling. So we know that coupling and cohesion. Coupling is happening in the interaction between the system. Cohesion is the interaction within the system like that. So here we are making the loose coupling. So whenever we talk about the loose coupling, here the observer pattern promote the loose coupling by allowing the subject and the observer to operate independently of each other like that. And third one is the event notification. So as per the event notification, here the subject that maintain a list of observers and broadcast the changes by calling all the notification methods and so on. And how it works, the event that observer pattern, how the observer pattern in event handling, how it works in the working principle in the sense, first, it based on the registering the observer. So all the register, the observer subscribe to specific subjects to be notified and often any relevant state changes and the event. And second thing is a state change in the subject. When an event occurs or the state of the subject changes, it invoke a method to notify all the registered observer. Third thing is the notification and update. So notification and update, here each observer implement and updates with a method and also called by the subject when an event happens and so on. That's why all the way notification and updation to be happening. And the next unregistering observer is nothing but here the observer can unsubscribe when they no longer need to receive the notification, allowing for efficient resource management and so on. So that's very important about the observer pattern. And the different use cases is nothing but it's a first use case is a graphical user interfaces, and second is whenever we use the logging and monitoring of the system. So in that cases, it will be useful. And next, binding of the data, and finally, the real-time updates in the collaborative software like that. So this is about the different use cases in the event handling based on very particularly in the observer pattern like that. And next, the factory pattern for the object creation. So the factory pattern is a creational design pattern that is used in the software development for simplifying and managing the process of any object creation. So instead of instantiating the object directly in the code, the factory pattern it provides a factory object that create the instances of the classes for you. So what are the key concept of the factory pattern in the sense? First key concept is the encapsulation of the object creations. So here factory pattern that encapsulate the instantiation logic within the factory, but keeping the creation detail hidden from the client like that. Second thing is the polymorphism and flexibility by using a common interfaces or the superclass, the factory pattern that allow the factory to create the object of the various subclasses of the child classes that enabling the polymorphic behavior where the client code can work with multiple type objects without knowing the other specific classes and so on. And third type, the type of the factory pattern, it may be a different types, simple factory, factory method, and abstract factory. So simple factory is nothing but a basic factory that create the object based on the provided parameter, typically using the conditional statement. And second thing is a factory method is nothing but it defines and it mainly defines an interface for the creating the object, allowing the subclasses for altering the specific type. And finally, abstract factory is a more complex factory method for producing the different family of the related object without specifying the concrete classes and other detail like that. And how it works in the object creation is nothing. In that cases, the working principle of the factory pattern is first all the way define a common interface for the super classes. So in that cases, first it should define a common interface or the abstract classes that's created that object that will implement like that. Second thing is it create the concrete classes. So in that concrete classes, we know we have to create the concrete classes that implement the common interface or the inherit from the super classes. So these are the actual type of the object that the factory will instantiate like that. Third thing is to implement the factory. So implement the factory here. The factory class contain a method and that return the instance of the required classes like that. And fourth one is a client request object from the factory. So here the client requests of an object from the factory rather than directly using a constructor or some other method. And the different use cases. So very particularly when the exact type of the object is determined at the runtime. So for example, here this kind of software application might choose the different types of database corrections like connection like MySQL or PostgreSQL or so some other databases, and to centralize the object creation for the better management and the complex creational logic, and finally creating the families of related objects. So the multiple objects are created. So these are the different use cases for the factory pattern for the object creations like that. So that's about the thing. And the next thing in the modeling the game objects. That's a very important, modeling the game objects uh, using the classes. So the modeling the game object using the classes here, it actually it's a common and effective approach in any kind of game development, and it leveraging the object-oriented programming principle to represent the various entity and element within the game world. So that's why this method allows the developer to define the structure of any classes, behavior of any classes, and also interaction between the classes of some object in the modular, reusable, and scalable way. So that's why the key concept of the modeling the game object within the classes is first one is object-oriented programming. We know the object-oriented programming enable the creation of the classes to represent the game entity using the concept like encapsulation, abstraction, inheritance, polymorphism, and so on. And second key concept is the classes as a blueprint. So a class is act as a blueprint of the system or blueprint of the object that all the way creating the instances within the game are like that. So a lot of examples are there. And third key concept is the inheritance and polymorphism. Even that inheritance also allow the creation of the parent-child relationship and like that. That's about the thing. And what are the steps to model the game object within the classes in the sense? First, we have to define the base classes. So first step is defining the base classes. Second step is we are all the way we are creating the derived classes. So third, we have to define the attribute and method in the both the way, and use a composition and additional features. And next, update the game logic using the object like that. So this is about the modeling the game object using classes. And next one is the level design and scene management with the OAD. So in that cases, whenever we talk about the level design and scene management with OAD, here the level design and scene management is an essential part of the game development that determines the structure, layout, and progression of the each player's experience. So that's why here the object-oriented design can be applied to organize the levels and scenes using the classes and object, and also providing a structured and reusable and modular approach like that. So here is how the OAD principles what can be leverages for the level design and scene management. The first one is a level design with object-oriented design. Here, the level design involves the creating the environment challenges and progressions within a game, and using the what the OAD principle, the developer can create a system of classes to model the various elements within a level, including the terrain, obstacles, or some kind of objectives or enemy or whatever it may be. And second thing is what are the components in the key component in the level design in the sense like first is the environment. So already I told you that the environment is very important whenever we go for such kind of game design. So the environment, it include the terrain, building, or any property or anything for the physical structure of the level. Each of these elements can be represented by a class with the shared behavior and attribute. Second thing is object and obstacle. Here the obstacle such as it may be a kind of barrier or traps that mainly for what are used for the interactable object that affect the gameplay and some other thing. Third component is the enemies and NPC. So enemies and non-player characters are the assigned in a dynamic object with the behavior like movement, attack, and dialogues like that. So fourth one is a player objectives. So the player objective is nothing but here the goal within each level, such as collecting the item or reaching the certain checkpoints are the crucial for the level design. That's the thing. So that's about the key component in the level design. So whenever we go for implementing the level component with the OAD, is something to be needed. The first step is defining the base class. So base game object class to be needed. Then after that, we are supposed to create the derived classes for the specific element. And third, we have to design level as a collection of the game object. And fourth, we have to load and configure the levels in the dynamic manner like that. And second thing is the scene management. See the two important thing, level and scene management. The scene management mainly refer to the control of the different scenes, screens or scenes, and the stages within a game, such as any menu or loading screens and the different levels and so on. So in that cases, whenever we talk about the scene management with OAD, actually it's implementing the scene management. In that cases, first we have to define a base what the scene class. That's a it's act as a base class, and we have to create the specific scene classes, and we have to implement the manager, scene manager, and also we have to manage all the transition between the scenes. So then only it will actually act as we have to make it in the dynamic manner. Then only it's act as a movement. So like that. So that's about the what is the scene management. That's a very important thing in that scene management with the OAD like that. So next, another very important thing, what is the artificial intelligence in games using OOAD. So how we are designing the games using OOAD based on that AI environment, artificial intelligence like that. So in that cases, AI is actually it uses some algorithm for creating the lifelike or strategically challenging behavior in an NPC or any game object. So by applying the OOD principle, AI in the games can be organized as a modular, maintainable, and scalable structures and so on. So here is a look at how that AI games AI in the games is built and managed using the OOD concept. First, the key component is we have to make all the way have to make the movement and pathfinding. So the movement and pathfinding is nothing but here NPC, that non-player characters need to navigate the game world and often around the obstacles, and which requires some algorithm that may be a Digital algorithm, or it may be a A-star algorithm or like that. That's a movement of the movement and the pathfinding like that. So second component is a decision making. So in that cases, here also the NPC, non-player character, that decide how to act. It's based on the player action or the current game state. So here we are using the technique like the final state machine or a behavior tree or even the decision tree concept or like that. Third component is the combat and interactions. So here the NPC, the non-player character that engage with the player and other object, what often involving the complex behavior for the attack and some kind of defenses or something. Fourth component is the environmental awareness. Here all the way the NPC provide, or it can perceive the game what environment through the line of the sight of the other range-based directions are like that. That's the environmental awareness like that. And next, the implementing our AI with the OOD is nothing but here the basic AI structure is to be needed. It's based on the character class, and we have to all the way we have to create the NPC class with the AI behavior that's to be needed. Third is a decision making using the final state machines, and pathfinding is needed.
ప్రొఫెషనల్ పోతామన్నమ్మా ఏంట కత్తురా ఇంట இந்த போட்டோ காமிச்சு திட்டுறாங்க ప్రొఫెషనల్ ఇంట போட்டோ இல்ல
Yeah, am I audible? Somebody is talking. Okay, so this is almost the last topic. So it's a very useful for you. The case studies here actually object-oriented design in some popular game. So every games actually you people are aware about that games will see. So here actually the object-oriented design has been very particularly very crucial in the game development due to its ability to encapsulate some kind of complex behavior and make the code reusable and also improve the maintainability and so on. So based on that, the first case study 1 and 2 is a Minecraft and Sim series. So some people are aware about the Minecraft and Sim series. So in that case, the first the Minecraft actually the key object is mainly to include the block entity and the player. And the design principles of the Minecraft, it mainly uses the encapsulation to handle the different block types like grass, water, lava. That's act as a subclass of the different basic or block classes. So here the entity class is a superclass for the dynamic object like a mobs, player, and animal, and so on. So if you are familiar with that Minecraft, then you can interact easily. You can interrelate all the things with that game. And next thing is the what is the what effectiveness. So the effectiveness of this Minecraft game is easily expand the game by adding the different types of blocks and entity without rewriting the major part of the code and so on. So that's about Minecraft. And second case study is a Sim series. So the main key object of the Sim series, it include the all the way it include the Sim object and environment and some kind of action. And the design principle is it mainly leverages the inheritance concept for creating the various subclasses of the what objects such as the furniture, household item, or under the super classes and so on. So that's why in that cases, some objects have the attribute like the health, the mood, and even some relationship where that influence the behavior and the interaction between the each other. That's the thing. And finally, effectiveness is the it allow the each sim to operate simultaneously anonymously using the encapsulated attribute and method to interact with each other in the sim environment, resulting a complex and dynamic gameplay experience and so on. The next third and fourth case study is a Grand Theft Auto GTA series and Pokemon series. So Pokemon series, everybody aware about the Pokemon series. So the Grand Theft GTA series is nothing but here the key object mainly include vehicle, NPC, player, and building. So the design principle, it may be based on that inheritance and polymorphism for the vehicle types and NPC types and so on. And the effectiveness of this GTA series is it enable consistent and predictable interaction between the player, NPC, and vehicle and so on. And second, next thing is the Bookman series. The Bookman series here the key objects are the Pokemon trainer, move, and battle. That's very important. And next, the design principle is each Pokemon is an instance of the Pokemon class with the classes for the specific Pokemon type, like a fire, water. So that inherit the property or attribute like the defense and some other attacking and level-oriented applications and like that. And finally, the effectiveness of this Pokemon series is allow the developer to add a new Pokemon or moves or some features with minimal changes to the code structures and so on. So that's the thing. Next, the future trends in the object-oriented game development. So whenever we talk about the future development trends in that game, the first very important thing actually it's what integration with the AI and machine learning. So in that cases, a lot of things, adaptive NPC, procedural generations, so a lot of things to be happening in integration with the AI and machine learning. And second thing is a component-based design over the pure OOPs. So in that cases, we are using the entity component system, the flexible modularity, and that's about the second thing. And third future trend is nothing but it's a use of the better use of the real-time physics and 3D engines. So in that cases, we have to all the way have to use the enhanced physics engine and the 3D object library and so on. So the fourth one, the cross-platform and the cloud-based games. So the cross-platform and cloud-based games, it may be universal object class or some type of streaming support and so on. And next thing is a VR AR integration. It's actually nowadays a lot of research is going on very particularly based on the AR VR and some games already actually it's developed under the use. Actually, it's used by the end users. So that's the thing. It's enhanced interaction model and spatial awareness and so on. And next thing is a cloud-based multiplayer and persistent world. Here is some kind of scalable object for the large world, real-time updates and so on. And next is actually it's advanced animation and behavior tree. I actually whenever we talk about the advanced animation behavior tree, here mainly the behavior driven. It's a kind of behavior driven development and even realistic character animation and so on. And next improved asset management and memory optimization. And next the improved modular game development and open source collaboration. And finally, it's a increased use of the object-oriented design in the procedural and narrative design like that. So these are this 10 point is a future trends. So suppose if you go for any kind of research or any what the project or anything, you can choose this 10 topic, any one topic. Based on that topic, you can choose your project as a UG or PG or research like that. So these are the future trends in the object-oriented game development. And finally, actually, I'm concluding the session here. Whenever we talk about the object-oriented design in the game development, here applying the object-oriented design in the game development has a proven essential for creating the uh, what structured, scalable, and maintainable code bases, especially in today's complex environment. By organizing this code around the object that respond the game entity behavior and even some kind of interactions and so on. So that's why in principles of actually it's principles of encapsulation, inheritance, and polymorphism, it mainly allow for the complex games interactions while ensuring that the code remains modular and adaptable. So additionally, object-oriented design that enhances the collaboration in game development team, allowing the different developers to work on the various aspects of the game like that. So as the gaming, the trends continue to evolve with the new technology like AI, AR, VR, and cloud computing. The OAD remains adaptable, offering a solid foundation that can integrate in the emerging architecture and like that. In particularly, it's a powerful OAD is a powerful approach in game development that provides the flexibility and structure needed to support the creative, scalable, and immersive gaming experiences like that. That's why it's adaptability will keep it at the forefront in the industry. Continues to innovate, pushing the boundaries of what games can achieve like that. So with this short conclusion, just I'm concluding my session. So thank you so much. So any queries? So any queries? Any queries? Are you all there? Okay. So if no query, then we'll conclude the session. Thank you so much.
Thank you very much, sir. On behalf of K.Ramakrishnan College of Technology, the Department of Computer Science and Engineering, thank you so much for this activity lecture on object-oriented design and game development. Thank you, sir.
Thank you. Thank you so much. Thank you.